2, f of x equals x to the fifth minus 405x plus 7. This is a fifth power function, quintic function if you will. Same questions, intervals of increase, decrease, maximum, minimums, and concavity inflection points. I'm not going to go through as much detail this time because all the explanation is exactly the same. The only difference is we have a fifth power instead of a third power. But first off, I'm going to find the first derivative of f prime of x, which is going to be 5x to the fourth minus 405. And the second derivative of f double prime of x is going to be 20x to the third plus 0, right? Constant, so we get 0. And the first parts, A and B, are asking me about increasing, decreasing, maximums, minimums. That's all first derivative information. And the second, or the last question here, C, is asking me second derivative information. So again, I've found my first and second derivative. They're useful information. So I'm going to create a box up here every time that has all my derivative information up there. So anytime I need to refer back to a derivative, I have that in my possession. Depending on the function itself, sometimes first derivative and second derivative are very simple to find. Sometimes maybe there's a product rule, quotient rule, a chain rule, whatever. You have to differentiate what you're looking at. So you have to do a derivative based on whatever derivative you're looking at. All right. Find the first and second derivative. If they're more complicated, I would do the derivative on a separate sheet of paper and just bring my end result derivative over here to put on the paper. I like to look at just nice finished products for derivatives because there's enough work involved in finding the increase and decreasing intervals and the concavity stuff like that. So give me the derivatives, but again, if it requires more than just multiply and deduct a power, then you might want to go on a spare sheet of paper, find a derivative, come back to your regular sheet of paper. All right. So increase, decrease intervals, I'm looking for critical numbers of first derivative, so I'm going to take the derivative expression 5x to the fourth minus 405, set it equal to 0. Again, there's a three-step criteria here. Step 1, derivative equals 0. Step 2, derivative's undefined, never. Step 3, endpoints, don't see any. So the only criteria that we have to consider here is the equal 0 criteria. Again, there's no x cubed, x squared, or x to the first power, so I can just solve this by getting x isolated, dividing both sides by 5, and then taking the fourth root. As long as the power is even, 2, 4, 6, 8, whatever, you have to put plus minus. If it's an odd power, you simply take whatever the sign is. So third root, fifth root, seventh root, whatever the sign is, what it is. Fourth root or square root or sixth root, whatever, you're going to put a plus minus. And the fourth root of 81 happens to be 3. So plus or minus 3 represent critical numbers. Again, undefined doesn't happen, and endpoints don't happen. So those are my only critical numbers. I'm going to start from negative infinity, and then from negative infinity to negative 3 to 3, and then from 3 to infinity. In the event that there are endpoints, don't start at negative infinity, start at your endpoint. So let's say an endpoint was negative 6 and positive 6. My answer will be negative 6, negative 3, negative 3 to 3, 3 to 6. The end. And if it was a equals, then they'll be bracketed on the 6 and negative 6. All right? But typically there aren't endpoints on the ones we're going to be doing more often than not. So negative to positive infinity is normal. Okay, again, I want to pick numbers on the interval, so negative 4, 0, and 4 look good to me. And what I want to do is evaluate f prime of x at these numbers to see if it's positive or negative. Let's start with 0 because it's easy. 0 minus 405 is negative, right? Okay. Anybody off the top of their head know what 4 to the fourth power is? 256, good try. 256, he was almost there. 256 times 5 is 1,000 something, right? Mm-hmm. Minus 405 is positive, and whether it's positive or negative, of course, it's going to be positive, right? Yeah. So both those are positive. If you don't know that, or if you didn't want to go through the mental exercise of doing that, you can always type in your calculator, 5x caret 4 minus 405. Go to your table, type in negative 404, and you see positive, negative, positive. Again, just know that we're not going to be, these aren't ordered pairs, these are just telling me signs. All right, so we're not finding answers here. Okay. I know the graph increases, then it decreases, then it increases, because that's what the derivative tells me. The graph's increasing, decreasing, increasing, whatever, or flattening out. Flattening out when the derivative equals 0, flatten out here and here. It goes from increase to decrease, so it's a maximum. It goes from decrease to increase, so it's a minimum. And just like that, we've got all the information we need to answer part A. So part A, we're going to say increasing on negative infinity to negative 3, and from 3 to infinity. And it's decreasing, oh, and I should put a union symbol there between those. All right, and it's decreasing on negative 3 to 3. And for part B, I know it's got a local maximum of something at x equals negative 3, a local minimum of something at x equals positive 3. To find the exact numbers there, I go back to f of x. I'm going to go y equals, I'm done using the derivative now, so I can just clear that out. X caret 5 minus 405x plus 7 table, and I'm going to type in negative 3 and 3, 979 and negative 965. Look how much bigger those numbers are. We went from third power to fifth power. Increasing the power makes the numbers a lot bigger, a lot quicker. So it's going to go pretty much straight up at 3, come back down, go back up. If we were trying to graph it, we'd have to scale our graph a lot to be able to graph this. All right, for part C, when does this equal 0?
When x equals 0.
X equals 0. So my intervals will be from negative infinity to 0, from 0 to infinity. I'm going to pick negative 1 and 1 again. Those are my favorite numbers to pick when I got those intervals. I'm trying to evaluate this function here at these two numbers. When x is negative 1 cubed is negative 1 times 20 is negative 20. 1 cubed is 1 times 20 is positive 20. It's going to be concave down and concave up. It's concave down from negative infinity to 0. It's concave up from 0 to infinity. And the inflection point will be 0, comma 7. Again, once I determine where the inflection point occurs, again, anytime I see concavity switch and inflection points occurring, 0 is the x-coordinate, the y-coordinate is found from here. 0 minus 0 plus 7 makes 7. So again, that was my question. Those were all my answers to the questions they asked me. And again, I know this graph's going to look a lot like the other graph did, except it's going to go way up and way down before it hits those flat points.